All right, now that we've taken a look at some sum problems, so addition, let's take a look at what happens when I have two polynomials that are being subtracted. Okay. Now, recall what we said a minute ago, that if I have any two numbers, A and B, in parentheses, that the parentheses don't affect them. I want to rephrase this. What if I have three numbers? A plus, and I messed that up already. Say I have three numbers, A minus B minus, or C, and I'm going to put this part in parentheses. Is that equivalent to this? Take a second to think about it. The correct answer to this is that it's not. These two statements are not equal to each other, okay? And this is the reason why. When I have a negative sign outside of a parentheses, what I really have here is a -1. And you'll notice it's right next to the parentheses. This is going to force me to distribute that -1 inside, which, if I do that here, that's going to give me A minus B plus C. And that certainly is not equal to A minus B minus C. So what does this mean? It basically is just saying that those parentheses do matter when we're talking about subtraction. And so we've got to be really careful when we're doing these problems that we check the sign. Okay? Check the sign before you begin. For both 7 and 8, it's not addition, it's subtraction. And so we have to be careful. Now, like I said, there's really an invisible -1 right there. And so before I do anything else, I am going to have to distribute a -1 into every single term in my second parentheses. Notice there's no -1 out front. That's not there, okay? So we don't have to do that here, but on the second parentheses, we'll have to. Well, nothing's changing. Like I said, nothing changes in the first parentheses, so let's just rewrite this. X minus 28 plus 6x squared. And then if I distribute -1, all that's really doing is changing the signs of things. So the opposite of positive x is going to give me negative x. And guess what? The opposite of -7x squared is going to be positive 7x squared. And so just by distributing, I've finally been able to reduce this a little bit. And you might have noticed that once we get here, it's just a combining like terms problem. So it's just like 5 and 6. I'm going to combine my terms that are like terms starting with the biggest exponents. So 6x squared plus 7x squared, well, that's 13x squared. And then x minus x, oh, this is a fun one. Any variable subtracting itself is just going to cancel out. So those are both gone. They've canceled each other out. They don't exist anymore. And so the only thing that I have left is just this minus 28. And so this is actually my answer. 13x squared minus 28, which, if I notice here, is one of my 4 options. It's option C. All right, one more together. If you want to pause this video to try it out, I encourage you to do that. So pause it at your own free will. I am going to keep going. So you had your opportunity to pause now because I'm going to explain how to do this one. First step, again, let's distribute that -1. The number one mistake I often see students make for these types of problems is just forgetting to distribute to all of the terms. So a lot of times people will just distribute to the first term and then forget to do it to the other two. You have to be careful about that because you will get the problem wrong. All right. Let's get rid of I don't need those parentheses because there's nothing happening there. That's going to become -m squared minus 6m plus 4. All right, let's start with our biggest exponent. That's the -m squared. Nothing to combine it with, so I just bring it down. Then I've got 2m minus 6m. That's going to give me -4m. And then my last one is 6 plus 4, which will give me positive 10. And I should notice that that one matches up with A. And we're finished.